The universe continues to expand at an ever-increasing pace, stretching the very fabric of space and time itself, pushing the limits of our comprehension. Back in 1929, scientists made a groundbreaking discovery that would forever change our understanding of the cosmos. The elements that make up our bodies, the very building blocks of life, were formed in the fiery hearts of stars. This revelation opened a new chapter in our exploration of the universe. Then, by 1957, we realized something even more awe-inspiring, that the sky, so often admired for its beauty, was not just a majestic backdrop, but a powerful testament to the vast and unrelenting forces of the cosmos. Yet, even with all this knowledge, we find ourselves still grappling with the mysteries of the universe. We continue to ask ourselves deep questions: why do we exist? Why do planets and stars fill the void? And what might other potential futures hold for us? For much of human history, we've been passive observers of the universe. Often, we ignore problems until they become unavoidable and critical, issues that, if left unchecked, could have serious consequences for our future. One such pressing issue is unfolding right now, with Betelgeuse, one of the largest and most famous stars in the night sky. Recently, this immense star has shown signs of instability, trembling and shifting in ways that suggest something extraordinary and potentially alarming is happening deep within it. Scientists have long been fascinated by Betelgeuse due to its incredible size, so massive that it makes our Sun seem almost insignificant by comparison. If you were to place Betelgeuse in our solar system, its outer layers would extend far beyond the orbit of Jupiter. Yet, despite its enormous size, Betelgeuse is not as close as it might seem. It lies over 640 light-years away, a distance so vast that even traveling at the speed of light, it would take over 640 years to reach it. With current technology, such a journey is beyond our reach, and would take millions of years, far longer than human civilization has even existed. This immense distance gives us a sense of just how powerful Betelgeuse truly is. For most of its life, it has burned steadily, but recently, it has shown signs of unrest. Stars, while appearing calm from our perspective, are in constant motion, undergoing complex and dynamic processes. Betelgeuse, as a red supergiant, is a star in a constant state of flux. Its brightness fluctuates in cycles, expanding and contracting as it moves through different stages of its life. These cycles can span from a few months to several years, with its brightness varying from a dim magnitude of 5 to a much brighter magnitude of 0. This dramatic variation in brightness is not random, it follows a predictable pattern, providing astronomers with crucial data about the star's internal processes. In February 2021, Betelgeuse's brightness dropped to an all-time low, which deviated from its usual cyclical patterns. This dimming event has raised even more questions about the star's future. What does it mean for a star of such size and age to suddenly become so dim? The answer is rooted in the star's internal processes. Betelgeuse is much cooler than our Sun, with a surface temperature of around 3,500 Kelvin, compared to the Sun's 5,500 Kelvin. This lower temperature makes it appear redder and less luminous, despite its massive size. Despite being one of the largest stars known to humanity, Betelgeuse emits less energy per unit area than our Sun. This paradox is a result of the unique nature of red supergiants, massive stars that have already moved past their main sequence phase and are now in the process of burning heavier elements like helium in their cores. Despite Betelgeuse's relative stability for most of its existence, recent events suggest that it is now transitioning into a more volatile phase of its life. The core of the star is running out of hydrogen, the fuel that powers its nuclear fusion process. As this fuel diminishes, the star's outer layers begin to expand. This expansion is a natural part of the life cycle of a red supergiant. As the star's core, now mostly composed of hydrogen, accumulates helium, the fusion process shifts from hydrogen fusion to helium burning. This new phase of fusion creates heavier elements, like oxygen and carbon, while releasing energy that pushes back against the force of gravity trying to compress the star. However, unlike hydrogen fusion, helium fusion is far less steady, leading to unpredictable energy releases. These bursts of energy cause the outer layers of the star to expand and contract in dramatic cycles, manifesting as the pulsations we see in Betelgeuse's brightness. The pulsations not only alter the star's appearance but also release enormous amounts of energy, generating powerful stellar winds that tear away large amounts of mass from the star's outer layers. This is a characteristic feature of red supergiants, and Betelgeuse is no exception. These winds strip the star of its outer material, gradually altering the balance of matter and energy within it. As the star continues to expand and contract, the cyclical pulsations become more pronounced, offering a fascinating look at the inner workings of a massive star. To study these cosmic behaviors, astronomers use several methods, including photometry and spectroscopy. Photometry allows scientists to track the amount of light emitted by the star over time, giving them insight into how its brightness changes. This method directly connects to the star's behavior, providing a real-time view of its pulsations and their effects on its luminosity. On the other hand, spectroscopy analyzes the light emitted by the star at different wavelengths, revealing key details about the star's temperature, motion, and the processes occurring deep inside it. As Betelgeuse pulsates, its spectral lines shift, providing valuable data that allows scientists to better understand the forces at work inside the star. Together, photometry and spectroscopy allow scientists to build a complete picture of the star's behavior, revealing how its internal dynamics influence its external appearance. But the science doesn't stop there. Using powerful computer models, astrophysicists can simulate the conditions inside Betelgeuse, from the fusion processes at its core to the fluid dynamics that govern the movement of matter throughout the star. These models allow astronomers to predict how the star's pulsations will evolve as its internal conditions change, providing an essential link between theory and observed data. This process helps refine our understanding of how massive stars like Betelgeuse behave and evolve throughout their lives. One of the most fascinating processes occurring inside Betelgeuse is stellar convection. Energy generated at the star's core moves toward the surface through convection currents, balancing the internal processes with the star's external brightness. As hot matter rises from the core and cooler material descends, these convection currents transport energy to the outer layers, causing the star to brighten when the energy reaches the surface. The movement of matter within the star alters its luminosity, causing it to fluctuate in a regular cycle of pulsations. These changes in energy flow are responsible for the periodic alterations in brightness that we observe from Earth. These pulsations are not random, they follow a rhythm that reflects the star's ongoing expansion and contraction. As Betelgeuse's outer layers expand, the surface cools and dims, while during contraction, the surface heats up and brightens. This cycle is the result of the ongoing battle between gravity, which pulls the star inward, and radiation pressure, which pushes outward. The delicate balance between these two forces creates the periodic changes in size and brightness, which we observe as regular pulsations. As Betelgeuse nears the end of its life as a red supergiant, these pulsations will become more intense, marking a dramatic conclusion to its life cycle. Eventually, the star will exhaust its nuclear fuel, leading to a supernova explosion that will release an immense amount of energy and mark the final chapter in the life of this massive star. But until that day comes, Betelgeuse's pulsations continue to offer astronomers valuable insights into the workings of the largest and most dynamic stars in the galaxy. What will happen to Betelgeuse in the coming years? Will it explode in a brilliant supernova, or will it continue to pulse in unpredictable ways for some time? Only time will tell. But for now, Its behavior remains a subject of intense study, offering a rare and fascinating glimpse into the heart of a star on the brink of death. Let me know what you think in the comments, and don't forget to like and subscribe for more thought-provoking discussions about the mysteries of the universe.